Good afternoon, everyone. We'll still wait. We are 1 minute early, so we'll wait still a little bit before we start today's CompoSIDE webinar, which is an introduction to CompoSIDE's unique BomGen bill of material generator tool. So if you bear with us maybe another minute, we will be starting this session. I'm here myself, Julien Cellier, the Managing Director of CompoSIDE. I'm here together with Jonathan Evans, John, who is going to go through the live demonstration part of the webinar a bit later on.
Hello, everyone.
Okay, so we've got quite a large list of attendees today with various companies involved in different market sectors where composites are either well established or growing. To give a list of the few market sectors that are represented, we've got the marine industry, where CompoSIDE has got quite a footprint today. We've got the civil engineering industry and the supply of components, representation in the oil and gas, in the wind energy, and as well from a few material manufacturers. Okay, so during this webinar, we'll have an introduction of the BomGen capability, the CompoSIDE bill of material generation tool. Then there'll be a demonstration showing the different ways you can build a bill of material, depending on whether you've got already an existing product, in which case there are some automated functions that help you to summarize the work that you've performed, the engineering work, and to summarize it for other parties in your organization or customers or suppliers. And there is in the demonstration as well a very good overview how to build a bill of material from scratch without using the automated functions of CompoSIDE. So BomGen as a mix of automated and let's say manual functions to give best flexibility to the user. And finally, we'll conclude on how BomGen can benefit by being used in your organization. Okay. So we'll John is playing tricks with the slides, missing a slide and trying to make it more difficult for me. We'll first show a brief introduction of the CompoSIDE workflow, describe what is BomGen and how you can benefit from it, and then the live demo from external data, so manual creation, and the live demo with a fully automated BOM. Finally, as usual, we'll have a question and answer session where you'll be welcome to ask your question to both of us, and we'll do our best to reply constructively. Okay, there it's what the bill of material has got different challenges depending on whether you're dealing with a single component part or whether you're dealing with a component made of multi-parts, so multi-part assembly. But typically, one of the issues of the composites industry is that we've got many references to deal with different usage, wastage factors, as well as you know, to yield the best benefits of composites, we've got to deal with multi-references. Here you've got an overview of, let's say, rather complex project which used probably too many references, but it shows also the capability of CompoSIDE to be able to get away from a spreadsheet approach, which can be particularly painstaking in some instances. The reality of BOM generations. For designers, basically they tend to be quite boring. It's not the most valued part of the work. It's a necessary evil to summarize what we do, so the purchasing functions, depending on whether the bill of material is used as a preliminary stage or at a quoting stage or so. It's a required document, but it's generally time-consuming, laborious, and really boring for the designers or the engineers to perform, which is where we do believe there is a nice value proposition from BomGen. It tends to be static and disconnected, therefore not updated within your project. It's prone to error because very often you rely on in-house tools. You've got different wastage factors depending on the type of material, how it's used, and all those parameters you can address very easily using CompoSIDE. And also, it can become extremely complex for multi-part assemblies. When you talk about a yacht structure, you've got 50, 100 structural components that you need to blend together to come up with an overall usage of materials. For project stakeholders, there is no standards for bill of material. It's about the quantity, about the result. Usually it's something that is painful, that requires resources to be consumed. And as we said before, it's not the best. We consider it a relatively poor resource utilization to spend a lot of hours just documenting the work that you've just done. So using this, let's say, this pain points from using bill of creating bill of materials, John will now go through the CompoSIDE workflow and show you how to make the most of BomGen. As usual, we advise to give it an on try yourselves, either on your trial or subscription package. And obviously, our team is always here to help you through. If you've got a particular example, we are always available for a short discussion to help you to define your topology and to use the best workflow for your particular application. I'll hand over now to John.
Thanks, Julian. So just before we jump straight into CompoSIDE, I just want to run through, for those who may not be familiar or haven't had a great deal of experience within CompoSIDE. So just an overall workflow of what CompoSIDE does is goes from project management in project space, where you can define your analysis settings, your bill of material settings, and setting up your general project. We'll go into a bit more detail of that later. Then we've got CMDB, which is our materials data management software. So CompoSIDE does give you a selection of materials to engineer and design with and create bill of materials with. You can input your own properties. You can generate properties using micromechanical apply generators, or you can import your material properties from an Excel spreadsheet, which you may already have. And you can also export and link this up with your advanced FEA software such as ANSYS, Nastran, Patran, etc. So then the next step is to create a laminate, which we do in LaminaSpace. We specify a laminate in here using materials generated or input in CMDB, and then we can calculate engineering properties based on those plies. The next step typically is a 2D section analysis. So this is a typical beam or section of a hull, as an example. Gives you basic beam 2D section properties and allows you to really quickly iterate on a preliminary design. The next step from here is to go into FE space, where we go from 2D to 3D. We can analyze grillages in here, panels and grillages combined, and do basic FE calculations and models. Now from there, we go into the bill of materials and automated reporting, which is where we're going to focus on today's webinar. Bill of materials basically takes all of your data of your plies, your materials, your cores, all of your analysis, and combines it into one module for each of your components and collates it all, where you can generate an automatic report at one click of a button. So let's just go into, Julian already mentioned what BomGen is. So it's an automated and integrated bill of materials and weight estimation tool dedicated to composites projects. So this is specifically designed for composites. We've recognized the pain points and we've tried to develop a tool which allows you to mitigate some of these pain points. In BomGen, you can create manual elements and automatic elements. Manual elements you can create directly from CMDB or laminar space, just by applying areas, lengths, coverage, etc. You can also apply manual beam elements, so you can grab it straight from section space, or you can generate beams within BomGen. You can also add just reinforcements and bonding laminates, just as a basic accounting for these type of plies, any metallic inserts, cores, any adhesives that you may use and may have not designed with. Automatic elements are generated from FE space, shell and beam models. So if you've done your analysis within FE space and section space, it will grab all of that data and combine it into one bill of materials. You can also generate it from YachtsCant, so any ISO or GL specific scantlings takes those panel sizes and laminates and then combines your whole yacht or motorboat into one bill of materials. So let's do it live. We've got a project brief, which is a composite facade. We need to generate a bill of materials with weight and material cost for a basic composite facade. You can see an image of that on the screen. And we also need to provide laminate tables for engineering drawings. So let's jump into CompoSIDE. So here we have the CompoSIDE environment. As you can see, the workflow goes from left to right. You may see some of these icons familiar. So we've got project space where we set up our project. CMDB where we've got our materials. Laminar space, we've got our laminates. And then we're going to skip through section space, FE space, and YachtsCant and just go straight into BomGen. So if I just show you a basic laminate which we've created and used for our bill of materials. It's a very basic laminate, just a quadriaxial 800 grams standard modulus carbon with an epoxy, and it's going to be infused. Okay, so let's jump into BomGen, the real focus of this. And we're going to create a bill of materials as a manual project. So I've got two products in here, one which is manual and one which is automatic. So within my product, you can see that I've got an overview of the designed areas of my product, but I haven't got any materials in here at the moment. I need to add some in. So in here, I have to edit the default area. So this is the area of my facade. Let's call it 5 meters squared. And the default length is used when you add in bondings or reinforcements. So I'm just going to keep that as a 1 meter long reinforcement. So safe. And then when you right click on a group, you can create a surface element, create a beam, a bonding or a reinforcement. So these are our manual elements. Let's bring in our laminate from earlier. So cladding laminate, and it's going to be our subcomponent area. This is already defined from our group, and component area 100%, and there's going to be one of them. So let's put it all in. Okay, so you can see I've got it in my tree with a little M signifying that it's a manual element. If you bring in an automatic element, you'll see an S, and you'll be able to update these material quantities as you go. So what I have to do now is select the plies and their coverage. So I know they're all going to be 100% of coverage. So I just select them all by dragging and then put in 100% and save and close. Okay, so that's updated. So I've got my basic cladding laminate. I want to add in a basic reinforcement, or sorry, a basic bonding. So I'm going to create bonding and just call this cladding bonding, and I've got this length of 1 meter, and there's going to be 2 bondings for each side. Okay. So in here I can add in homogens, so adhesives. basic epoxy adhesive I've got in here. This is quite a simple project. I've only brought in a few materials filtered out of what we've got in CMDB. So 50 mil wide, add that in, and I'm going to add in a couple of adhesive fillets. Okay, so it's going to be one fillet. Because I've already got 2 quantities of bondings, and then I can add in my plies as well. So I've got a biax, which is vacuum wet, 400 gram, and I'll add in 3 of these, and these are going to be at 45 and a width of, let's say, 150 millimeters. Okay, so in here I can add a quick comment. So bonding. For these plies, I'm just going to add in that 30 plus 20 mils per ply. Just so when I export this as a laminate table, it will automatically be in the Excel spreadsheet. Okay. So from this, if I go into my product, I can see my as designed area and my total area. So the difference between these two are any manufacturing or usage, wastage, ply overlaps, etc., which you can define manually within each project or product or your whole environment.
So this also this is a boundary between the engineering bill of material and the manufacturing bill of material that takes into account the wastage of cuts and whatever material losses you get when you build a part.
And then that's translated into as designed weight and total weight. So if we were just to break it down into 2, as designed area is going to be the basic area once it's been trimmed, and the total area is what you would use to order materials, for example. Okay, so this is a very basic bill of materials. Okay, so let's create one more manual element here. We're going to create a reinforcement, and we're going to call this edge closing, for example. And this is going to be the perimeter. So this is going to be 15 meters, and it's going to continue around the whole edge of the panel. So let's edit this, and then we're just going to add in a couple of plies, same plies as we did before. 3 plies at 45 and a width of 200. Okay, we'll call this edge closing. Okay. So now that we've defined all of our manual elements within our product, we need to convert this into a drawing. So from here, we can export the laminates, so everything that we've created, into a laminate table. We can also export a bill of materials material table, which gives you an overview of all the materials and material properties. So for a drawing, the best one to do is export material table. This just opens up in an Excel file, which is on the screen. Okay, so in here, this is a standard format for a laminate table that we use. You can just copy and paste this directly into your drawing. So there's no recreating of any material quantities or elements or thicknesses, etc. It's just a basic copy and paste. Okay. So going back to the presentation, the usage factors and wastage factors that we mentioned earlier, just a visual prompt of what they are. So it's just any plies which come outside the trim line of the component, any overlaps of plies if they're 45, 90, whatever, and any design core areas. So yeah. Okay. So that was a manual bill of materials generation. Let's run into a automatic bill of materials generation. So back into CompoSIDE, and we'll go back into FE space. So I've created this landing panel within FE space. I brought it in from a step file, applied a laminate to it, defined a load case, a basic pressure load case, and run the analysis. I've optimized my laminates, and I'm happy with the results that I've got. Takes a few seconds to load. Try again.
Okay, well, whilst it loads, we will we can discuss about some of the things that John has been demonstrating. Basically, with by means of using the bonding, the surface element, and the reinforcement, you can basically create any composite part that exists. There is also a beam wizard that helps you to create beams in a simpler way, just specifying the shear web, the capping, and then it scales up everything and does the work for you, basically. So I think your model came up finally.
Yep, yeah. Finally. So you can see here that I've got just a basic cladding panel, and I've run my analysis on it. So I've got one of my tasks here. You can see this is just basic deflection. You can have a look at the reserve factors for the panel, the strains for the panel, but we won't run into that today. So what BomGen does, when it generates an automatic bill of materials, it takes the material data based on the mesh that's being generated. So if you want to generate a bill of materials, you always have to have the latest mesh. So from this, we can jump straight into BomGen, because I'm happy with the mesh, it's updated. So in BomGen, and I generate, and it will bring in all of the data. You can see that, okay, it's 3.2 meters squared. This is all automatically calculated. The only thing I would have to do now is to create the bondings and the edge closing. So pretty easy. If you're creating a big grillage, or creating a lot of panels, a lot of small panels within an FE model, or you're generating a few FE models with different components for your product, it will take all of that data and combine it all into one bill of materials. Okay. So there's one other element that we haven't talked about, which is the reporting side of things. So once we have a bill of materials, we can, I'll show you the manual product. So we can also create a BomGen report. So we give you a set of standard templates, which you can use for your products or your bill of material reports. So let's just call it a BOM report. And we'll use one of our templates. So we'll use a simple summary. You can also go into much more detail, all components with costs. So depending on the topology of your project, you can go into as much detail as you need, but we'll just go for a basic, simple summary. Would just be an overview of the material quantities required for this product. Okay, so once we have it here, you can export to HTML or generate a PDF. So if we have an HTML, you can copy and paste this link to someone, and they can view either that issue or the latest issue which you've generated. So what I'm going to do is I'm going to paste the link in the chat so you can have a look at this bill of materials. So, okay, send. So you can see here, this is a very a basic template, but it saves you a lot of time when you're generating these reports. You can also go into these and edit, generate your own templates as basic HTML coding. So just edit what we've given you, or create your own. And this gives you all of the details, including the BOM settings, all of the files that you've used within your project.
Yeah, I think it's worth maybe just showing a few of the elements here. You've got the overall summary, okay, in terms of square meter or kilos, depends on which unit make sense to the product. Total quantities of formulated products, total weight estimate, description of the cores, and so you should be able to, well, a purchasing person will be able to link the reference with the format, with the type of core pre-processing that you're using, and specifying within BomGen. You've got the detail of your formulated products and a short description of the reference. Here you've got the BOM settings, and that's maybe what John is going to explain briefly afterwards. It's about how you manage the material quantities estimation between the engineering bill of materials, so what the net weight of the structure is going to be on completion, and whatever you've been processing as quantities of material to achieve the delivery of the final part. Okay. We tend to consider two elements: wastage, which are things that are thrown in the bin, okay, and usage, which are parts of materials that either end up in the final part or are processed still. They will end up in the bin, but after being processed. Okay. You can see that there are a number of key factors that, as a user, you can you can tune for each of the components and each of the sub-components. So John is going to show you that briefly. But there is an overall scale factor, finished part of cut. So if we take the example of a hull or a deck for yacht, you'll have for a hull you'll have about 10 or 15%, well, maybe less, probably 5% of cuts on a hull, whereas for a deck, you're going, because of the shape of the front of the foredeck, you're going to end up more in the region of 15 or 20%. So in that particular case, your bill of materials for each of the components will have different scale partial factors, wastage factors. Sorry. General resin usage is, for example, whatever is left in the pipes after you've been infusing in the infusion tube, in the infusion mesh, and all these are really to be used carefully, and in the fact that you need to get some input. The way we tend to recommend to work is to submit a small, let's say, blank bill of material, and to ask the manufacturer for his input on those different parts. Usually the engineer has got the responsibility to develop the design and summarize the material quantities. There we do a bit more by going into the manufacturing, but they still it's still based on assumptions. Okay. And then depending on your process, various overlap factors. Again, as a user, you can adjust all this. There is some default values that are made available, not to be a blocking factor, but it's the responsibility of the user to use those appropriately to get the actual material quantities that are to be used.
Okay. So just going into the project space where we set up our project. Within here, you can set up your bill of materials factors, which we're going to run through. Your analysis setting factors, so your reserve factors, your safety factors attached to loads that you apply. Not sure why it's not working too.
Your CompoSIDE is on strike.
Might be the internet connection. Or my browser, or my computer.
Why not the user?
Okay, so here we have our project. We can see our materials in here. So if we go into edit settings and then project BOM settings, this is where we can set it. So we've got our default adhesive for secondary bondings. We've got our default materials used within our product. So this generally is going to be dependent on or in your company. These are used when your usage and wastage factors are automatically implemented by CompoSIDE. And then you've got your processing defaults. So for your processing type and your pre-processing for your phone calls.
It may vary project to project depending on your specific requirements.
Yeah. So in here you can see we've got our wastage factors based on fabric offcut, adhesive wastage, and resin application wastage. And these are set different for each of the processing type. So from spray up to winding, protrusion, pre-preg, compression molding, they're all separate. And these are something that we find that our customers tend to enjoy tuning to their
process particulars.
Yeah, exactly. Yeah. And then we've got usage factors, which is general usage factors and resin bleed out. Again, these are very specific to clients, customers. Core density variation, overlap factors. So whether your overlaps are quite large, or whether you're trying to keep weight down, you're working with pre-pregs, your overlaps are maybe 20, 15 mil. This depends on the type of product and your manufacturers. And then we've got core resin consumption. So this is the amount of resin that's absorbed into the foam through each different type of process. Okay. So you can edit these yourself.
So on the phone, John, if we scroll down to the settings, so by editing, the user has got the ability to adjust the settings to the particular of its project. This big table for the core resin consumption is basically an input of core bonding usage depending on different types of grooves, grooving patterns that can be found for core materials, right?
Mm-hmm. Yeah, exactly.
Okay. Okay. And basically those numbers is for both the total core bonding weight used for both sides, yeah, and the grooves,
exactly,
and to fill the grooves. Okay. Okay. The data for this has been generated using data provided by 3A Composites, who manufactures the C70 and T92 and T10 PETs. Obviously, the user can adjust, but we are pretty confident on the validity of those as far as they come from real application feedback.
Okay. So jumping back into the presentation. So I think we've shown that CompoSIDE can be used for rapid estimation of laminate quantities and total part weights for any components, with a very easy way of generating deliverables and additions to drawings, which saves you a lot of time. Okay.
Okay, do you have now it's our turn to listen to the audience. There's a chat box available in the platform where we sent the HTML file for the bill of material. If any of you would like to ask us a specific question, please go ahead, and we'll do our best to answer it. We'll probably leave you 30 seconds to a minute to come up with a topic of your choice.
Okay, so we've got one question. When using YachtsCant to feed the BOM, is it necessary to define both port and starboard panels in YachtsCant in order to get an accurate representation in the bill of materials generator? No, I don't. I think you can just put in one side. There is the function to create or input the quantity of your panels. So as long as you're equal around the center line, you would get a good representation of your material quantities for your whole vessel. Okay. Another good one. Is it possible to add center of gravity values in BomGen? Yes, it is. We've used this quite a bit recently. You can put it in for each of your topology groups, and then CompoSIDE's then automatically calculates your whole product center of gravity from that. Okay. All right. Okay, another one. Do you provide material properties for CompoSIDE users to use and design with?
Yeah, we have a CMDB add-on which has far too many material properties, about 12 to 1300 materials that are characterized here and fit for calculation, and it includes basically all the physical properties of the material, which are the one which matters in CompoSIDE. Basically, most of the CompoSIDE platform is driven around structural requirements. BomGen is driven around the physical properties to be able for the engineer to liaise with the other functions in the business, be it a purchasing manager, a project manager, a customer, or a supplier. Okay. I think that covers us for today. John, do you want to bring back the presentation? So basically, as we mentioned earlier on, we would recommend that you try on your own on one part that makes sense to the business, and we've got the chat available within the platform. So our team is available to help you and to walk you step by step, so you take ownership and you succeed in doing what you want to do with CompoSIDE and BomGen specifically. Basically, there is no limitation on the type of part that can be dealt with. There might be a few workarounds here and there, but our team will be helpful when it comes to workflows to get through. Okay. The tangible benefits that were gathered from our client feedback was through the use of BomGen was improved efficiency, the fact that it's easily accessible and scalable, and it saves them quite a lot of valuable days of entering resources by having a system and a method to deal with this, and a database handling of the various parameters which are material process dependent. Obviously, improved quality and consistency of the deliverable is a strong point, and the link with integrating the laminate table into the drawing with the weight usually is greatly appreciated by manufacturing engineer. So they've got a clear target to deliver that helps them in their quality control to have both the engineering and the manufacturing bill of materials. A quick summary of our subscription plans for those of you we are still waiting to commit to your CompoSIDE subscription. I will just stay on the professional edition. We've got excellent deals. Come to us with your requirements, how you wish to use CompoSIDE, how you think it could be useful to your business. Again, we'll help you to adapt the workflows so it becomes a software of choice in your organization. Okay, I think we are here. We still have on our support and training pages a number of video tutorial, knowledge base and technical documentation that is available. I think that's it for us today. Thank you very much for your attention. It's been pretty good on the dashboard provided by the platform. Should you have any specific requirements or points of discussion, we will address them separately. Thank you very much. Thanks for your attention.
Thank you, everyone.
Have a good day.